Okay, I hope the screen is visible. So first let us start from the important topics from the chapter Amines. Then we will move to the questions, past paper questions. Okay. So first let us see what are the different methods for preparation of this amines. So the first method we can see, that is the reduction of nitro compounds, because nitro compounds means there is a nitro group, right? So this nitro group can be reduced to NH2 group or amino group. Okay, and here we have to use some reducing agent as well. So we can use palladium or tin HCl. Okay, so this reducing reagents are important. So in the question it will be like they would give the they would give the reactant, they would give the product as well. So we have to see the reagents, or sometimes it will be reactant and the reagents will be there. We have to find out the products. So those kind of questions are also there. Okay, so see here, ammonolysis has the disadvantage. Before that, see here the second one, that is ammonolysis. First one is the reduction, second one is the ammonolysis. So in ammonolysis, we can see ammonia is reacting with alkyl halide and they are producing the substituted ammonium salt, right? Now this substituted ammonium salt on reaction with sodium hydroxide, they are converting into primary amine. This is another one. So these are the different kind of two different kind of methods: reduction of nitro compounds and ammonolysis of alkyl halides. Okay, now let us see the ammonolysis. It has a disadvantage of yielding a mixture of primary, secondary, tertiary, and also quaternary ammonium salt. So if you do this ammonolysis, sometimes you are getting primary, because see here this primary will be produced, right? This primary can react with more amount of alkyl halide and they will convert into secondary. The secondary again react with more amount of alkyl halide and they will produce tertiary. So here there is a possibility for getting mixture of primary, secondary, tertiary and quaternary ammonium salts. Okay. So in this reaction, but the thing is, primary amine is obtained as the major product by taking large excess of ammonia. That is the thing. Okay, so order of reactivity of halides with amines can be written as Ri greater than Rbr greater than RCl. Okay, and another thing is aromatic amines cannot be prepared because aryl halides are less reactive towards nucleophilic substitution reaction. So this is also important. We can prepare aliphatic amines, but if you want to prepare aromatic amines, this is not possible. We cannot use this reaction. Okay, that is the thing. Now we can see reduction of nitriles or cyanides. If you have nitriles or cyanides on reduction, this nitriles can be converted into corresponding amines. This is another one. Okay, so here this alkyl group is having suppose 3 number of carbon atoms, but in the product you can see 4, because this R group plus one more CH2 carbon is there, right? So this is always producing an amine with one more carbon atom. That is the thing regarding this process. Means you can prepare the amines with more than one carbon atom than that of the reactant that you have taken. Okay, so that is the thing. Now let us see the reduction of amides. Reduction of amides means, see, amides on reduction with lithium aluminum hydride, they can be converted into primary amide. This is another thing. So all these reactions you have to memorize. These reactions, reaction medium, reaction conditions, everything you have to memorize. Okay. Now you see Gabriel phthalimide reaction. In Gabriel phthalimide reaction, we have a phthalimide. They are reacting with potassium hydroxide and are converting into potassium phthalimide. And this potassium phthalimide on reaction with alkyl halide, they would convert into N-alkyl phthalimide. So these are another kind of reaction. So this N-alkyl phthalimide, again reacting with potassium hydroxide, they are converting into potassium phthalate. And another product is primary amine. So here primary amine is producing as the byproduct of the reaction. Okay. So all these methods you have to remember, write it down, the points. Okay, hope the points are noted down. Now let us see the remaining. That is Hoffmann bromamide degradation reaction. Okay, so Gabriel phthalimide reaction is clear. Next is Hoffmann bromamide degradation reaction. In this reaction also we have an amide. They are reacting with bromine and sodium hydroxide and converting into aromatic primary amine. Okay, so this is the reaction. So this amide on reaction with bromine and sodium hydroxide, they are converting into primary amine plus sodium carbonate plus 2 NaBr. So this is the reaction. Now we have the alkylation reactions, right? So when amines react with alkyl halides to produce quaternary ammonium salt as the final product provided alkyl halide is present in excess. So this reaction, all these reactions you have to remember. Okay, next one is acylation reaction. In acylation reaction, see these are the chemical reactions of compounds. See here, this primary amines can be converted to acetanilide. Okay, so this is a kind of acylation reaction. Now we have benzoylation. This reaction is shortened Bowman reaction. Then carbylamine reaction. This is only for primary amines. And we have reaction with nitrous acid as well, that is HNO2, and they are converting into the corresponding alcohol. Okay, so these are the reactions, and quantitative evolution of nitrogen is used in estimation of amino acids and proteins. So this is another kind of reaction. So all these reactions are very important. So note it down. Now let us see the reaction with aryl sulfonyl chloride. So this is Hinsberg reagent, Hinsberg test, right? So when the reaction between benzene sulfonyl chloride react with primary amine, they are producing N-ethyl benzene sulfonyl amide. So this is another kind of reaction, and here also this reaction is important. This you have to memorize. Okay, now the reaction of benzene sulfonyl chloride with secondary amine is also given. So when the secondary amine is there, you are getting a product, but this is insoluble in alkali, but the first one is soluble in alkali. So these two are different, right? So primary amine is producing a product which is soluble in alkali. Secondary amine is producing one which is insoluble in alkali. So these two products are different, that you have to note down. Okay, note it down. Okay, done. You have written everything, right? Next one is reaction with aldehydes. So when the amines react with an aldehyde such as benzaldehyde, we are getting the product which is called Schiff's base. This is obtained by reaction between in presence of zinc chloride. Okay, this is also important. So the reaction is amine react with benzaldehyde in presence of zinc chloride. They are producing Schiff's base. Schiff's base is benzylidine aniline. This is called Schiff's base. Okay, so this reaction is also important. You just remember the how we are producing this Schiff's base. That is very important. Okay, write it down also. Then, so the next one, that is the electrophilic substitution reactions in amides. So if you take aniline, that is the aromatic aniline, aniline is ortho and para directing towards the electrophilic substitution reaction due to high electron density at ortho and para positions. So when you do this electrophilic substitution of aromatic amine, you are getting the products with bromine substituted at ortho and para positions. Okay, so this is the electrophile because bromine is acting as an electrophile in presence of this reaction medium. So in presence of this medium, they are acting as electrophile, and this electrophile is substituting the hydrogen atoms present in this aromatic ring at ortho and para positions. Okay, so this where they are doing this substitution is important. And now this is called 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. Okay, now here see, this is a light yellow colored precipitate, that also you have to remember. So the color of the precipitate is also important. Write it. Okay, so the next one, nitrogen. In the nitration also we can see this aniline is undergoing nitration. See, before nitration means it is not possible to do the nitration of aniline because it is susceptible to oxidation. So the amino group is first protected by acetylation reaction. So first we are, in order to introduce the nitro group, as in case of as in case of the previous reaction, we can see the bromine is directly substituting the hydrogen from the benzene ring. But here that is not possible. The nitro group is not able to replace the hydrogen. Got it? So means this nitro group is not possible means first this the reason is this NH2 group is also there, right? This NH2 group will undergo oxidation. So we have to protect this NH2 group before we do this nitration reaction. Then the remaining molecule will be only undergoing this reaction and they will produce the corresponding product. Okay. So here in order to do the nitration reaction, first we have to protect this NH2 group by acetylation. So this NH2 group will be converting into the corresponding acetylated group and they will convert into the substituted nitro product. So here also the group is still NHCOCH3. Then finally by the hydrolysis, base hydrolysis, they will convert into the NH2 group. So this is the product. Okay, write it down. So hope this is clear. Next one. See, in strongly acidic medium, aniline is protonated as anilinium ion, which is meta-directing. So it gives meta products also. In the previous reactions, we could see that they are producing the ortho and para substituted products, right? But here we have ortho. If you want to produce meta product instead of ortho and para, we can do the reaction in strongly acidic medium. Because in strongly acidic medium, this NH2 group will be converting into NH3 plus group, that is anilinium ion will be produced. Thus, anilinium ion is a meta-directing group, whether the remaining group may be ortho or para-directing, but anilinium is actually meta-directing group, so they will produce the meta products. Okay, so means meta products is also possible. Not only ortho para, meta products will be also produced in a large amount. See, 47% is the meta product, but ortho and para will be also produced, but para is the major, 51%. Okay, that's it. Now coming to the sulfonation. Sulfonation means we are introducing HSO3. This group will be introduced, right? So this can be done by treating with sulfuric acid at a temperature 453 to 473 Kelvin. They will produce sulfanilic acid and zwitterion. So this is the reaction. Okay, that's it. Okay, so next one. Aniline does not undergo Friedel-Crafts reaction due to salt formation with aluminium chloride, which is a Lewis acid, which is used as a catalyst. So due to this, nitrogen of aniline acquires positive charge and hence behave like a strong deactivating group for further chemical reaction. So this is important because for all the other reaction like electrophilic substitution with bromine, nitro group, everything takes place, right? But here this is not possible. Means Friedel-Crafts alkylation or acylation. That is alkylation means we are introducing CS3. Acylation means we are introducing COCS3. These two reactions are not possible. These two introductions are not possible in case of aniline because when aniline because Friedel-Crafts reagent is what, that is aluminium chloride, anhydrous aluminium chloride, right? So this anhydrous aluminium chloride when react with this aniline, they will produce the salt instead of the product. So this is not possible. Okay, write it down. Okay, now next one, benzene diazonium chloride. So if benzene means when aniline react with sodium nitrate and HCl, that is called diazotization. Okay, when this aniline is undergoing diazotization, they will produce benzene diazonium chloride. Okay, that is the reaction. So what is the use of benzene diazonium chloride? Benzene diazonium chloride can be used as the starting reagent for many reactions. Using the benzene diazonium chloride, we can prepare some other compounds as well. So the thing is, benzene diazonium chloride is important. They can be used as a starting reagent for many other reactions. Okay. Okay. Now, the next one, stability of arene diazonium salt. The diazonium salt, as I told you before, they are used as the starting material for many reactions. And this diazonium salt is actually, there is stability for this arene diazonium salts. Okay. So if you come to their stability, we can see that is the destability, means the delocalization of electrons. That's why they are stable. So this jumping of electrons or their delocalization of pi electrons is important. This is how they are becoming stable. And there are some chemical reactions of these compounds as well. Note it down. Now, the next one, see, these are many other reactions as well. So these reactions are also important. Write it down. Okay. Next one. So these are the important topics. Hope all the points that you have written down now. We have to see the past paper questions from the chapter, same chapter. Okay. So let us go through the questions. So the first question, we have two statements here. The first statement is aniline does not undergo Friedel-Crafts alkylation reaction. Second one, aniline cannot be prepared through Gabriel synthesis. Okay. So what about this reaction? See, what about the statements? Aniline does not undergo Friedel-Crafts reaction, alkylation. This is a true statement because we already explained it, right? Next one, aniline cannot be prepared through Gabriel. So we can ignore option B and option D, right? Option B and D are wrong. Now, aniline cannot be prepared through Gabriel synthesis. Gabriel synthesis is the carbylamine reaction. So, aniline cannot be, means they cannot produce it, right? So, here first statement is the correct one. Aniline cannot be prepared through Gabriel synthesis also correct statement. Okay. Now, coming to the second one, the compound that does not undergo Friedel-Crafts alkylation reaction but gives a positive carbylamine test. Okay, so which is the correct answer? The compound that does not undergo Friedel-Crafts alkylation reaction but gives a positive carbylamine test. C. Aniline, they cannot produce the Friedel-Crafts reaction, right? Yes. And but gives a positive carbylamine test. That is possible, right? So aniline is the correct answer. Okay, so here we have different reaction. We have to find out the reaction which will not give primary amine as the product. Which is not producing the product, which is not producing primary amine. That is the question. So first one is an amide. They can produce, right? So this is not the correct answer. Now CONH2. This is again amide. They can also produce primary amide. It's also not the correct answer. And coming to the next one, CS3CN. This will also produce. This is a nitrile compound. So they will produce the amine with one carbon greater than that of this reactant. Right? This we discussed before. Now coming to the last one, this is an isocyanide. So if you take an isocyanide, this will give secondary amine as the product, not primary amine. So a primary amine cannot be produced from this isocyanide. They can produce only the secondary amine. So the correct answer is option D because they are producing secondary amines. Okay, write it down. Okay, now the next question. We have to find out the product of the given reaction. So the reaction is we have a diazonium chloride of amine here sorry, benzene here, benzene diazonium chloride is here. So the reactants are also given. We have to find out which is the final product of the reaction. So first of all, we have to use each of the given reactants sequentially, means we have to use a sequence for the reaction. Then only we can find the final product of the given reaction. So we can start from the benzene diazonium chloride, that is N2Cl, right? Now first I'm using which one, which is the first reagent, Cu2Br to HBr. So when this benzene diazonium chloride react with Cu2Br to HBr, they are converting into bromobenzene. So this is the first step, right? So the bromobenzene is producing with the first reactant. Now the second reactant is magnesium in dry ether medium. So when this bromobenzene react with magnesium in dry ether medium, they are producing the product in which, like this. See, the bromine will be substituted by MgBr. So this is the second step. Now we can use the third reactant, water. When this compound is reacting with water, this compound will be entirely converting into benzene plus MgBrOH. So this will be the reaction. Got it? So the product is benzene. So the correct answer is option C. Other products are obtaining in between. So we have to find out the product which is obtaining in the last step. So after reacting with all the three types of reactants, the product is benzene only. Okay. Okay. Now coming to the next question. Here we have two statements and we have to find out the correct answer based on the two statements. So the first statement is primary aliphatic amines react with nitrous acid to produce unstable diazonium salt. And the second statement is primary aromatic amines react with HNO2 to produce diazonium salt, which are stable even above 300 Kelvin temperature. So what is the correct answer? First you can see when primary aliphatic amines and HNO2 reacts together, they will produce unstable. Okay. Now this unstable diazonium salt it will be converted to alcohol. So what is the reaction? First let us represent the reaction. RNH2 plus HNO2, and they are producing RN2Cl, and this on further reaction with water, they will produce alcohol plus nitrogen plus HCl. So this is the reaction. Now we can see the primary aliphatic amines react with nitrous acid. They will convert into unstable diazonium salt. This unstable diazonium salt further reaction with water, they will convert into the alcohol. Now when you take primary aromatic amines and HNO2, primary aromatic amines plus HNO2. Okay, so what is the reaction here? They also produce diazonium salt. Okay, they will also produce diazonium salt. Okay, they will produce diazonium salt, and the thing is they are stable at a temperature between 273 to 278 Kelvin. So this diazonium salt produced will be stable at a temperature of 273 to 278 Kelvin. So we can say the first statement is correct, right? Because they are producing unstable, and second statement is incorrect one because they are stable at a temperature 273 to 278, not 300. So the first statement is correct, second statement is incorrect. Option B is the correct answer. Okay, so write down the reactions and write down the products as well. Okay, the equation and the reaction conditions and how the products are obtained. That was so important. Write it down. Okay. Next question. Here, different compounds are given. Here we have to identify the compound that reacts with Hinsberg reagent to produce solid which dissolves in alkali. Okay, so here we have to find out the reagent which react with the Hinsberg reagent and produce a solid which dissolves in alkali, right? So first of all, we have to know what is Hinsberg reagent. Hinsberg reagent is having the formula C6H5SO2Cl, that is benzene sulfonyl chloride. Benzene sulfonyl chloride. Okay, so when primary amine, right, primary amine, this is a general reaction, react with Hinsberg reagent, they will produce N-ethyl benzene sulfonamide, N-ethyl benzene sulfonamide. Okay, at the same time, if you are taking a secondary amine, they react with Hinsberg reagent and they will produce N-ethyl, N-ethyl, N-methyl benzene sulfonamide. Okay, so these are the type of reactions. And if you take tertiary amine, there is no reaction. Okay, primary amine react with Hinsberg reagent and produce N-ethyl benzene sulfonamide. Secondary produce N-ethyl N-methyl benzene sulfonamide, and tertiary there is no reaction. So here we have to find out the compound which react with Hinsberg reagent to give a solid which dissolves in alkali. So coming to the first option, this is a tertiary amine. So this is not reacting with Hinsberg reagent. So option A is not the correct one. Coming to the option B, here we have nitro compound, not an amine. So nitro compound is also not possible here. Option B is also incorrect. Coming to the option C and D, here this is a secondary amine. Secondary amine can produce the product, and the third last one is a primary amine which also produce the product. But the one which produces solid which dissolves in alkali will be D, not C. So the correct answer is the primary amine, that is ethylamine CH3CH2NH2. So write down this. Fine. Coming to the next question. Here we have the reaction and the reagent is tribromoaniline, right? 2,4,6 tribromoaniline reacting with sodium nitrite and HCl. We are getting some product and that product again react with R and they are producing tribromobenzene. So we have to identify what is the reagent R in the reaction. In the first step, we can see the NH2 group is converted to diazonium group, N2Cl. And in the second reaction, the N2Cl is not there. That is removed by the hydrogen, right? So the reagent R will be what? We can say that the reagent R will be ethanol. That is CH3, CH2, OH, ethanol. Because this ethanol can act as a mild oxidizing agent here and they can convert the diazonium salt into arene. Okay. At the same time, the ethanol will reduce to ethanol as well. So this ethanol will be the reagent R here. So what they are doing? They are used as the mild oxidizing agent. Mild oxidizing agent. Okay, and they are converting the diazonium salt will be converted to arene. Okay, so this is the reaction takes place here. So R is not copper cyanide, not water. It is ethanol, option C. And it is not hydrogen iodide as well. So this reaction will not be possible. So option C, ethanol is the correct answer, which act as the mild oxidizing agent in this equation. And when they are oxidizing the disonium salt into arene, this ethanol will undergo self reduction as well, right? So they will undergo reduction and they will produce ethanol. So ethanol will be converting into ethanol. This is the reaction. Okay. Write down the equation and this reagent as well. Here, urea react with water to produce a compound A, which will decompose to produce B. Then B passed through CO2 plus aqueous solution and deep blue colored solution of C will be produced. What is the formula of C? So first we have to write the entire reaction. Then only we can see what is C here. Okay, so we can start from urea, that is NH2CONH2, urea. So what is the reaction? Reaction with water. When urea react with water, they will produce ammonium hydroxide, NH4OH, and carbon dioxide. So here we are considering the product A, that is ammonium hydroxide. CO2 is not A because urea is converting to a compound A, right? So urea will be converting into ammonium hydroxide, NH4OH. Now this NH4OH A, that is react, means they will undergo decomposition. So when this ammonium hydroxide undergo decomposition, they will produce, by heating, they will produce NH3, ammonia plus water. Okay, so B is ammonia. B is ammonia. Now, this B again react with CO2 plus aqueous copper ions. They are producing deep blue color solution of C. So this ammonia, which is B, when they are, I will write the equation separately. NH3 react with aqueous CO2 plus, that is CO2 plus ions in water. They will produce a complex. The complex will be CuNH3 4 times 2 plus. So this is the deep blue colored solution. Deep blue color because, okay, so the CO2 plus ions are the reason for blue color of the species, right? So here the complex, the compound C produced is a complex of copper and ammonia. So coming to the options, option A is copper hydroxide. This is not produced here because we have the reactant urea. Coming to the option B, copper carbonate and copper hydroxide. This is also not possible because copper carbonate cannot be produced in the reaction. And coming to option C, copper sulfate, which is also not possible here because copper sulfate is, in order to produce the copper sulfate, we need some other reagents, not urea. So in presence of urea, they are converting into ammonium hydroxide. This ammonium hydroxide on heating, they will produce ammonia. This ammonia is reacting with aqueous copper 2 plus ions and producing the blue colored complex, that is a complex of ammonia. So the correct answer is option D. Okay. Now the next question. Which of the following amines will give the carbylamine test? So first of all, we have to know what is carbylamine test. Okay. So usually the carbylamine test will be induced by the primary amines. Primary amines, okay, and they should be a both aromatic and aliphatic can be reduced carbylamine test. Okay, so carbylamine reaction is induced by the primary amines which are aromatic and aliphatic. So what is the reaction happening here? The aniline causes the carbylamine test because it is the main aromatic amine, right? So aniline is the compound. So from these options we can see all of them are aromatic in nature, right? Because they are containing benzene ring. But if you come into the first one, this is not amine. This is a tertiary, tertiary amine. So this is not the correct answer. And And from these kind of anilines, from these kind of amines, always aniline will be giving the carbylamide test. So B is not aniline, but C is aniline, right? That is aminobenzene, which is giving the carbylamide reaction. So the correct answer is option C, aniline. So here we have to find out the correct order of basic strength of methyl substituted amines in aqueous solution. Okay, so here we have primary amine, secondary amine and tertiary amine. We have to find out the correct order. Okay, so the correct order means always the secondary amines will be more basic, because basicity means it is the ability of a substance to accept H plus ion, right? It is the ability to accept H plus ions. And in terms of electrons, we can say it is the ability to donate electron pairs. Donate electron pairs. Okay. So if you take a primary amine means the nitrogen is connected to only one alkyl group and the remaining two will be hydrogens, right? So if you check the primary, secondary and tertiary, in order to produce primary, secondary, tertiary, we have to replace the hydrogen with the alkyl group. So the alkyl groups are usually showing plus I effect. What is plus I effect? Electron donating effect, right? So they have a tendency to donate the electrons, right? So due to this plus I effect, usually these secondary amines are highly basic in nature, because these plus alkyl groups present on the secondary amine will increases the electron density on the nitrogen, so they can easily donate the electron pairs, or they can easily accept the H plus ions. So you will be thinking like, if in case of a tertiary amine, what is happening, because they are containing three alkyl groups, right? So we are expecting, right, that is the tertiary will be more basic than secondary or primary, but we have to consider other steric factors as well. So three alkyl groups means they will be repelling with each other, right? So in order to for predicting the basic property, we have to consider both plus I effect and the steric effect. So if you combine these three effects, not tertiary, secondary will be more basic in nature, and then it will come to the primary, and the least basic will be the tertiary one. So from these options, the correct answer will be option A. So this is a combination of plus I effect, steric hindrance and solvation as well. Okay, because solvation is particularly hydrogen bonding, it is also playing a significant role for predicting the basic property. So combining all these three effects, we can say secondary will be more basic than primary, then tertiary. So correct answer is option A. Now coming to the next question. Here it is given that nitration of aniline is in strong acidic medium also gives meta-nitroaniline. What is the reason? So nitration of aniline in strong acid medium is producing meta-nitroaniline, because in strong acid medium this aniline will accept the H plus ion, right? So this will be converting into anilinium ion. Usually in aniline, the reactions like bromination, those those kind of reaction will take place at ortho and para positions, right? But in case of nitration, it will come to the meta position. The reason is aniline on acidic medium, they will abstract the H plus ion, and they are, means they are acting as a base, and they will produce NH3 plus ion or anilinium ion. This anilinium ion is different. This is meta directing. Anilinium ion is meta-directing. So on reaction with NO2 plus, that is nitronium ion, they will produce meta-nitro aniline. So this will be the product obtaining in the reaction. So the reason is the anilinium ion produced is meta-directing. That is the reason. Okay. So first option is, in spite of substituent, nitro group always goes to only meta position. That is not correct. Electrophilic substitution, amino group is meta-directive. That is not the correct answer. In acidic medium, aniline is present as anilinium ion. That is the reason. So D is also incorrect. Coming to the C, that is the correct answer because anilinium ion produced here is meta-directing group. Okay. So the next question. Here also we have three different compounds of amine. So we have to find out the correct increasing order of basic strength of following compounds. So we have to know what is a basic property. Basic property means it is the ability to release the electrons or accept the H plus ions, right? So which is the correct order for increasing the basic strength of given three compounds? So here we have three compounds. First is aniline, second one is paranitroaniline, and third one is paramethylamine. That is aminotoluene also we can say. So this compound, among these three compound, which is more basic in nature. So in order to write the basic strength, we have to find out which one is giving the electron pairs easily. So in the third one, we can see the CH3 group, right? What is the nature of CH3 group? CH3 group is a plus I group. Plus I group means electron releasing group. So when this CH3 is releasing the electrons towards the benzene ring, that is also increasing the electron density on the nitrogen atom. So the electron pairs on the nitrogen atom will be more available to donate to some other species. It means their basic property will be very high comparing to other two. While in case of the second one, we have NO2 group. What is NO2? NO2 nitro group is a minus I group. What is minus I group? They are electron withdrawing group and they will decreases the electron density on nitrogen. So they are no longer available to donate. So if you compare these two, this nitro compound with the nitro group substituted aniline will be least basic in nature, while this methyl substituted aniline will be more basic in nature. So coming to simple aniline, this will be in between these two. So we can write the correct order, that is the less basic will be the second one, then the first one, and the more basic will be the third one. So the correct answer is here option C. Okay, so this is the order of their basic property. Now, which of the following reaction is appropriate for converting acetamide to methenamine? So in order to convert acetamide to methenamine, we have to do Hoffmann bromamide degradation reaction. Okay, so in this reaction, what is happening? First one, we have to choose the acetamide, that is CH3CO NH2. This is acetamide. When they react with bromine in presence of sodium hydroxide, we can write the balanced equation for NaOH. They followed by heating, they will produce methenamine, that is CH3NH2 plus 2NaBr plus the side products are Na2CO3 plus 3H2. So this is the reaction. So this reaction means we can convert this acetamide to methenamine by Hoffmann bromamide degradation reaction. So the correct answer is option A, and write down this reaction as well. Okay, so this is an important reaction for the preparation of primary amine. So here we have the structure of pyrrole, and the question is, in pyrrole, what is the electron density is maximum on which of the atom? So in order to find out the atom which is having maximum electron density, first of all we have to know the complete resonance, right? So if you draw the complete resonance, we can see the electron density will be maximum at this second position and this fifth position. Okay, so option B is the correct answer. For example, in order to clarify, we can draw the structure. So we are starting from the structure of pyrrole. We have nitrogen here, These are the lone pairs. Nitrogen is having these are the bonds. Nitrogen is having lone pair. First, the electrons will move here, and these bonds will move on the corner atom, and they will produce. This is the structure plus. Then here you will get minus, right? And this is also here. So in the next step, this will come here. This will go to this corner, and you will get. So this atom is here. Now the negative is here. This is here. Okay. So what is happening in the next step? Here you can see this will come here, and this is moving here. Okay, this corner. So if you draw this structure continuously, you will get that this electron density is maximum at the second and fifth position. So these are the important questions from the chapter. Hope these are clear. So all the very best for your exam.